Hello. Yes, then comes this question. It says that the rate versus time graph below is for this equilibrium. This is the equilibrium we are having. And the statement says the changes at T1 and T2 are due to temperature. Okay, this is T1 and this is T2 on a rate versus time graph. And the question says state and explain the changes at T1. Okay. Yes, how do you go about that? Okay, this is what you have to know. Let us observe what we have at T1. First of all, what do we notice? The rate increased. So that's the first observation. Rate increased. Okay. And two, what happened? Reverse is favored. It is very important to know that this one is for the reverse and this solid one is for the forward. So what do we see here at T1? Reverse is favored. Okay. Yeah, so we can represent this on our equilibrium. If we have this one as our equilibrium, and after having it, you need to know that what you have here is for the forward. So forward is XO, reverse is ENDO. But you need to know that if it is a reverse is favored, reverse is ENDO. And the ENDO is favored by increase in temperature. So what are we going to say? At T1, temperature increased. What are the reasons? The reason is that rate of reaction increased and reverse is favored. Yeah, that is that. Yeah, then comes this one. It says that state and explain the changes at T2. And this is T2. What do we observe at T2? 1, rate decreased. You can see it from here. It was here, now it's here. And 2, forward is favored. Those are the two observations. I want you to know that rate decreasing alone can be used to predict what happens to the temperature, because decrease in temperature decreases rate. This is just another additional factor. So what are we going to conclude? We are going to say temperature decreased because rate decreased. And what are the reasons? The reasons are here. Rate decreased and forward is favored. Okay, forward is favored when temperature decreases. Let us see it here on equilibrium. This is exothermic, so forward is exo. What does that mean? That decrease in temperature favors XO. XO is forward. And that is it. So that is that. Yeah, then comes this question. It says, state what happens to the equilibrium constant at each one, at T1 and T2. Okay, we need to recall that temperature increased at T1. And we are dealing with an exothermic reaction. Exothermic reaction. Okay, what does that mean? For exothermic reaction, we need to know that increase in temp decreases Kc, and decrease in temperature increases Kc. So remember, at T1, what happened? At T1, temperature increased. So this is it. If temperature increased, what happens to Kc? Kc decreases. At T2, what happened? Temperature decreased. So it's here. When temperature decreases, what happens to Kc? Kc increases. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard. We urge you to subscribe, to comment, to like, to share. And we need also for you to know that Physical Sciences Silver Bullet is a YouTube science channel dealing with physical sciences, grade 12, 11 and 10, and natural sciences, grade 8 and 9. Our appeal to you is that when you're using our channel, don't go to video because of the wide scope of the channel. Go to playlist and choose the material which belongs to your level. For grade 8 and 9 natural sciences, it is written natural sciences grade 8 or natural sciences grade 9. Just click on the tile. For grade 11 and 10 physical sciences, it is written physical sciences grade 11 or physical sciences grade 10. So just click and everything will be at your exposure. For grade 12, each chapter is a tile. So just go to any topic of your interest and click. So everything will be there. We believe we are the best. Stick with us. Bye bye. See you next time.